Hello! Today we are going to follow the trail of a concept that we perhaps feel more than we consciously think about: beauty and symmetry. Symmetry is one of nature's oldest codes. From the wings of a butterfly to the structure of a crystal, and even the proportions of our own face, this order has for centuries been regarded as one of the fundamental measures of beauty. For mathematicians, symmetry has been the language of balance, proportion, and repeating patterns. For artists, it has been the invisible backbone of aesthetics. Today, we will explore why symmetry affects the human mind so deeply, within a broad framework that stretches from biology to art, from architecture to psychology. Defining beauty: the scientific foundations of aesthetic perception. Throughout history, beauty has been an ever-present concern for philosophers, artists, scientists, and societies. Yet, although it is often treated as something universal, its definition is remarkably variable and multi-layered. In philosophical traditions from ancient Greece to the present, beauty has at times been framed as an objective reality grounded in the order of nature, and at other times as a subjective experience based on individual perception. This multiplicity is what makes the scientific investigation of beauty both complex and inevitable. Modern science, particularly psychology, neuroscience, and evolutionary biology, attempts to provide objective foundations for understanding what beauty is. When individuals evaluate an object or a face as beautiful, this is not merely a matter of taste. It is also a neurological process involving the activation of specific areas of the brain. Functional magnetic resonance imaging, fMRI, studies show that exposure to aesthetic stimuli leads to pronounced activation in regions associated with the reward system, such as the medial orbitofrontal cortex, the amygdala, and the striatum. This demonstrates that the feeling of pleasure experienced before beauty has a clear biological counterpart. From the perspective of evolutionary biology, our sense of beauty appears to have adaptive functions. In early human history, features such as bodily symmetry, healthy skin tone, and certain body proportions were linked to genetic fitness and reproductive success. This suggests that the aesthetic criteria guiding people's preferences in potential partners are not solely cultural, but also evolutionarily encoded. For example, symmetrical facial structure has been associated with a stronger immune system, and symmetrical individuals tend to be perceived as healthier. Beauty, therefore, is not merely looking nice, but has historically been part of broader strategies of survival and reproduction. However, beauty cannot be reduced to biological or evolutionary bases alone. Cultural context plays a decisive role in shaping aesthetic perception. Each society attributes different meanings to beauty. In ancient China, pale skin was a sign of nobility and refinement, whereas in some African communities, body scarification and decorative markings could be symbols of attractiveness. Today, under the influence of globalization, Western-centered beauty norms have become widespread in many parts of the world. Yet alternative aesthetic approaches that challenge these norms are also gaining strength. In this sense, Beauty is not always a zone of cultural consensus, but often a site of contestation. Beauty is also a multisensory experience. It is not limited to the visual. It can be felt through sound, touch, smell, and even thought. The pleasure created by a melody, the sensation left by a touch, or the aesthetic structure of an idea all belong within the domain of beauty. This multisensory structure frees beauty from being confined to physical appearance and turns it into a field of experience and perception. In conclusion, beauty is a multi-layered concept arising from the interaction of biological predispositions, cultural norms, neurological processes, and individual experiences. To understand the scientific foundations of beauty is to deepen our understanding not only of aesthetic judgment, but of human nature and our evolutionary past. For this reason, beauty is not only a subject for art or fashion, but a common object of inquiry shared by biology, psychology, and the cultural disciplines. The golden ratio, harmony in numbers. The golden ratio, mathematically expressed as approximately 1.610, has for thousands of years been regarded as a symbol of aesthetic harmony. Appearing across a wide spectrum from ancient Greece to the Renaissance and from nature to art, this ratio is not merely a number. It is the mathematical expression of symmetry, proportion, and our sense of beauty. In simple terms, the golden ratio describes the division of a whole into two unequal parts, in such a way that the ratio of the smaller part to the larger part equals the ratio of the larger part to the whole. Because of this property, the golden ratio embodies a mathematical elegance while also explaining the harmony observed in natural and artistic forms. The history of the golden ratio stretches back to antiquity. Ancient Greek mathematicians such as Pythagoras and Euclid examined its geometric properties, and Plato regarded it as one of the fundamental principles of universal order and beauty. Represented by the Greek letter phi, the number appears prominently in Euclid's Elements. However, the systematic definition and naming of the golden ratio can be traced to 19th-century mathematicians. German mathematician Martin Ohm described this ratio as golden in 1835, and the term gradually spread through the world of aesthetics. The golden ratio is not confined to abstract mathematics. It appears strikingly across the natural world. The arrangement of sunflower seeds, the spirals of pine cones, the shape of seashells, and the angles at which leaves attach to stems, all frequently involve patterns close to this proportion. This has supported hypotheses that aesthetic harmony may rest on evolutionary foundations. Living organisms may have developed structures based on the golden ratio because such forms confer advantages in energy efficiency or function. For instance, the relationship between the golden ratio and the Fibonacci sequence helps plants maximize their exposure to sunlight. Art and architecture likewise bear the strong imprint of the golden ratio. It has been claimed that the facade proportions of the Parthenon are close to this ratio, and that Leonardo da Vinci's Vitruvian Man uses it to structure the human body. Renaissance artists such as Michelangelo, Raphael, and Botticelli are thought to have used the golden ratio consciously to achieve compositional balance in their works. In modern architecture, Le Corbusier based his modular system on the golden ratio, designing humane, functional buildings grounded in this proportional logic. Today, the golden ratio is widely used in graphic design, logo creation, photography, and product design as a key to aesthetic balance. The proportions of the Apple logo and the basic construction of the Twitter bird are often cited as examples. Yet some research suggests that the golden ratio does not exert a decisive influence on aesthetic preference in every context. Cultural and individual factors remain powerful forces in shaping our judgments of beauty. In short, the golden ratio stands at the point where mathematics meets aesthetics. It appears in both natural patterns and human creations, leaving traces of a possible universal order. At the same time, the fact that aesthetics cannot be reduced to a single formula only deepens the charm of the golden ratio. For beauty is not simply measurable symmetry. It is also a balance that can be perceived, a wholeness that can be felt. Facial symmetry, the search for balance in attractiveness. The human face is not only the first element that draws attention in social interaction, but also one of the most important arenas in which aesthetic perception is concentrated. Facial symmetry has long been regarded as a central criterion of beauty. But why? Why is symmetry considered so attractive? In this section, we will examine the relationship between facial symmetry and beauty through the lenses of psychology, biology, and culture. Facial symmetry refers to the degree to which the left and right halves of a face resemble one another. No human face is perfectly symmetrical, yet a certain level of symmetry is interpreted, especially in evolutionary psychology, as a visual signal of attractiveness. According to this view, symmetrical facial features indicate developmental stability and genetic health, whereas asymmetries may be associated with genetic disturbances, environmental stressors, or illness. Facial symmetry thus functions as a visible cue of good genes in an evolutionary context. Scientific studies show that people tend to judge symmetrical faces as more attractive. In experimental settings, computer-generated symmetrical versions of faces are often rated as more appealing than the originals. Nonetheless, researchers still debate whether this preference is rooted primarily in evolutionary pressures or in visual habits. Some argue that the human brain simply processes symmetrical patterns more easily, and that this cognitive ease translates into aesthetic pleasure. From the standpoint of visual cognition, symmetry provides a kind of mental relief, which in turn supports positive aesthetic evaluations. Facial symmetry influences not only our perception of beauty, but also our social judgments. In various experiments, symmetrical faces are more likely to be evaluated as intelligent, trustworthy, and healthy. These judgments are mostly unconscious, formed within a few seconds of exposure to a face. This reveals that aesthetic preference is not merely a matter of visual taste, but also part of broader social and psychological strategies. Symmetrical faces may enjoy advantages in contexts ranging from job interviews to political elections. At this point, however, an important distinction must be made. Perfect symmetry does not guarantee beauty. Symmetry is only one component of attractiveness. Facial proportions, the balance of features, the distances between the eyes, nose, the mouth, skin quality, and facial expression all contribute to our judgments. Cultural and individual differences also shape what is considered beautiful. Some societies favor pronounced cheekbones or broad foreheads. Others prefer softer contours. Today, facial symmetry has become even more visible due to cosmetic surgery and digital filters. Aesthetic practitioners seek to approximate symmetry through fillers, botulinum toxin injections, and surgical procedures, while social media filters perfect real faces by altering their proportions. These developments risk turning beauty into an artificial, standardized norm and can create psychological pressure, particularly on younger generations. The pursuit of symmetry may sometimes erase individuality and lead to an aesthetic uniformity. In short, facial symmetry offers a powerful signal that resonates with the brain's search for visual harmony. It plays a role at evolutionary, cognitive, and cultural levels in shaping attractiveness, yet it is far from being the whole story. Genuine appeal emerges not only from symmetry, but from the interplay of expression, character, and individuality. To admire symmetry is natural, but to confine our notion of beauty to a single ratio is to ignore the richness of the human face. Symmetry in nature, from flowers to crystals. Symmetry is not only appreciated by human observers, it is also one of nature's own signatures of order, efficiency, and function. From the arrangement of petals to the atomic structures of crystals, from animal patterns to snowflakes, the natural world is filled with symmetry. In this section, we will examine the kinds of symmetry observed in nature, their biological and physical basis, and their impact on human perception. One of the most common forms of symmetry in nature is radial symmetry. It is clearly visible in flowers, many marine organisms such as starfish and jellyfish, and some fungi. Radial symmetry is defined by repeated structures arranged around a central axis, such that the organism looks similar from multiple directions. This form allows living beings to respond evenly to stimuli from any direction. For example, a jellyfish can detect water currents and potential prey all around its body. Another widespread pattern is bilateral symmetry. Seen in humans and most animals, this type of symmetry means that the left and right sides of the body mirror each other to a significant degree. From an evolutionary standpoint, bilateral symmetry is closely tied to mobility. It enables efficient forward motion and has evolved in parallel with the development of centralized nervous systems. In plants, symmetry has both aesthetic and functional dimensions. The symmetric structure of flowers serves as a guide for pollinating animals. Bees and butterflies can recognize and remember symmetric flowers more easily. This demonstrates that symmetry plays an important role in plant reproduction. In some flowers, such as orchids, Reflective or mirror symmetry is not merely decorative but directional. It guides the pollinator to the exact location needed for effective pollination. Symmetry in nature is not limited to biological forms. Crystals, snowflakes, and minerals display some of the most striking examples of physical symmetry. A snowflake's six-armed symmetric pattern reveals both nature's elegance and molecular-level order. Each flake forms around the hexagonal lattice structure of ice. External conditions ensure that no two snowflakes are exactly alike, yet the basic symmetry is preserved. This shows how thermodynamic factors can shape and maintain symmetry. Fractal symmetry is another captivating natural structure. In fractals, small parts of a form repeat the shape of the whole. Ferns, Romanesco broccoli, river deltas, and the branching of the lungs all exhibit fractal characteristics. These patterns reflect nature's logic of scalability. Fractal structures are often associated with efficient use of space and effective transport of matter and energy. When the human brain encounters such symmetric patterns in nature, it responds with a sense of aesthetic satisfaction. Psychological research shows that people tend to rate symmetric and fractal patterns as both more beautiful and more calming. Thus, natural symmetry is not only a biological or physical phenomenon, but also a cognitive experience. In conclusion, nature does not use symmetry merely as ornament, but as a functional, evolutionary, and aesthetic tool. The shapes of organisms, the structures of crystals, the colors of flowers, and the designs of snowflakes all reveal this ordering tendency. Symmetry in nature not only offers beauty, but also teaches us how life is organized and how evolution operates. Symmetry in art and architecture, an aesthetic tool. Symmetry is a foundational element not only in nature, but also in human aesthetic sensibility. A look at the history of art and architecture shows that it has been one of the most powerful principles shaping civilization's ideals of beauty. In the pursuit of perfection, harmony, and visual order, symmetry appears as both a functional and a symbolic tool. In this section, we will examine how different cultures have used symmetry in art and architecture, what meanings it carries, and how it influences aesthetic perception. The earliest large-scale examples of architectural symmetry appear in ancient Egypt and Mesopotamia, where it often served as a representation of divine order and cosmic balance. Egyptian temples and pyramids were designed symmetrically along both horizontal and vertical axes, with central lines aligned with sacred pathways or celestial directions. Symmetry here was not just a visual arrangement, but a physical reflection of universal balance. In ancient Greece, symmetry was discussed together with the idea of proportion. The golden ratio in architecture expressed not only visual aesthetics, but also suitability to the human body and functional coherence. Classical structures such as the Parthenon are among the best-known examples of these principles. Artists of this period also paid great attention to bodily proportions in sculpture. In Greek statuary, the symmetry of face and body became almost synonymous with beauty itself. The Renaissance represents a peak in the use of symmetry. Leonardo da Vinci's Vitruvian Man is not just a depiction of human proportions, but also a symbolic diagram of cosmic order. Artists and architects of the time sought perfection through symmetry, informed by meticulous mathematical calculations. In church architecture in particular, symmetrical plans were read as visual analogues of divine order. In Islamic art, symmetry assumes yet another set of meanings. In Islamic architecture and ornamental arts, especially in geometric designs, symmetry evokes the concept of infinity. Mosque decorations, dome interiors, and calligraphic compositions are filled with repeating, fractal-like symmetric forms. These patterns point aesthetically toward the infinity and perfection of God. Symmetry is also prominent in East Asian aesthetics. Chinese temples, Japanese Zen gardens, and Indian monuments such as the Taj Mahal all display carefully composed symmetry. The Taj Mahal, in particular, is one of the most striking examples of symmetry used to embody love and grace. In such structures, symmetry is associated with peace, tranquility, and inner balance. In modern art, symmetry is no longer a compulsory rule. It has at times been deliberately broken. Still, in graphic design, logo creation, product aesthetics, and architectural plans, symmetry remains a primary means of achieving balance. Even movements such as minimalism and the Bauhaus, which emphasize simplicity, often rely on symmetry as a tool for visual order. In postmodern art and architecture, critical approaches to symmetry have also emerged. Asymmetry, randomness, and fragmentation have been explored as challenges to classical aesthetic norms. Yet, despite such experiments, symmetry continues to survive as a powerful expressive device in contemporary artistic production and design. Symmetry is not only an aesthetic principle, but also a mental pattern. The human mind gravitates toward order, recognizes repeating sequences, and processes symmetric structures more easily. For this reason, the use of symmetry in art and architecture can create a stronger bond between the work and its audience. In conclusion, the history of symmetry in art and architecture shows clearly how it has functioned as a tool in both the perception and construction of beauty. Every period and culture has interpreted symmetry according to its own aesthetic, philosophical, and functional understandings. Yet they meet in one shared reality. Symmetry fulfills one of the most basic aesthetic needs of human beings.